Get started. Okay, this is notes for Thursday, January 26th for 7th hour, and I'm recording this during 1st hour. And I can't remember if 7th hour we did 3C or not, but in 1st hour we had set up 3C, and we had set this up in this way. And had I given you, give me a head nod, had I given you time to kind of do that in 1st hour? Yes or no? Okay, and so this is 3C. We skipped 2 at the beginning of the hour. And will you just tell us how to solve for x? We're going to add 1 to both sides, and then x equals 3. And now that I'm thinking about this, I think 7th hour I did have them do this problem. And then we have to find QS also, so make sure that you know that. And so QS is this 4x minus 1, so 4 times 3 minus 1, 12 minus 1 is 11. And now I think we're kind of all at the same place. Now, the next thing that's going to happen is I'm going to go back to number 2, and here is number 2, and you should have that picture in front of you. And so I'm gonna actually pause my recording, and I'm gonna do something here, and I'm gonna ask that you do the same thing. So what you're gonna do is you're gonna send your supply getter to get rulers and protractors, and then I am going to give you compasses, or the teacher should give you compasses as well. So I'll pause that, you'll get what you need. And so now all students should have a ruler, a protractor, and a compass. The compass we're going to use very minimally, so just kind of keep that sitting down someplace. And when I go through this, it's a little bit hard for me to do it well, but hopefully we'll all be able to follow along. So what we need is the triangular shaped garden is shown. Can a fountain be placed at the circumcenter and still be inside the garden? Maybe you have a thought about whether that's going to work or not. But if you remember the circumcenter, so someplace by number 2, I want you to write the word circumcenter. And I also want you to remind yourself what the circumcenter is. And the circumcenter is the intersection of the perpendicular bisectors. And so we're going to just write perpendicular bisectors of segments in a just very short way, perpendicular bisectors of segments. So what you're going to do is you're going to use the ruler and the protractor to find the midpoint of each one of these sides, and then you're going to use whichever one you think will be best to draw the line perpendicular to those. So my answers will be different than yours, but I'll call on people to tell me what they get. Oops. So just take a few minutes and find the midpoint of ZY. And so on my board here, it's about 6.4, so that would be like 3.2 for mine. Who can tell me how long XZ is on yours? Somebody has to tell me that. How long is XZ? About 3.5 centimeters, and so half of 3.5 would be about like 1.7 or 8, kind of whatever you think is close to that. And so find that midpoint, and then I'm going to find XY next, the midpoint of XY. And so put your ruler on there. Mine is about 10.9, really. Let me see, yeah. And so halfway is about 5.5 is as close as I'm going to get there. How long is that one? Yep. That one is 6 for you, so you're going to use 3 centimeters as the midpoint. So find that midpoint. And then do the same thing for XZ. And mine's about 6.4, I'll say, so that's about 3.2. It's just a little less than that. And what was yours? 3.5 for the, is that the midpoint? It's at 3.5? Oh, the total was 3.5, and so the midpoint's about 1.7, 1.8 again, something like that. So you should have the midpoints. I'm just going to call them M, N, and P, just so that if I want to comment on them, I can. Now, your next job is to draw a perpendicular from each one of those, and I'm going to give you 2 strategies or a couple of strategies. If you need to extend one of these sides, you can do that. Sometimes that's a little hard to do once when the picture is already drawn on there. And so I will extend mine. But before you do that, you might just want to watch this first one and decide if you think you need to extend it. If I extend that out, it'll just be easier for me to make a 90-degree angle. You can use 2 methods. The method I personally would choose would be to put my protractor so that the the on your protractor, the hole is at N. I'll do N first. And I would line the protractor up with 90 degrees going out that way. And then I would just slide, since the hole isn't at the edge, I would just slide my protractor down like that, and then I can draw that. And so if you can tell where 90 degrees is without having that extended, that's fine. But if you can't, if your hole is at N and then it's coming out at 90 degrees, you can just slide it along there and that'll be a 90-degree angle. And then when you are at that point, then you're going to draw that line. And I'll draw them in kind of lighter colors just so that we can see them. And just a note to self, you want it to go above the picture quite a bit. It's going to need to. And you want to make sure that it looks perpendicular to ZY, that side. It has to look perpendicular to ZY. Maybe check with your neighbor just to make sure that you're agreeing with how these look. And then once you do that, then you're going to do the same thing on line segment XY. I'll put, oh, I'm drawing lines, just a second. I'll put the whole part at M again. This side seems a little longer, so I'm just going to kind of leave it as is. I'll put my 90 degrees there so I know that I'm making a right angle, and then I'll just slide it down so that I can just draw my line right at M. And theoretically, when these intersect, that should be the answer, but you always want to draw all 3 lines to just make sure that they're going to be concurrent. And remember, if we do a super good job, all 3 of these lines should intersect at that same point. So I've got the point there. And then I'm going to do the same thing with point P. There we go. With point P, I'm going to do the same thing. So I'll put kind of my hole on the protractor at point P. I'll turn it so that it's at 90 degrees. And then I'm going to slide it out a little. Oops. slide it out a little bit, and I can see before I even make that line. Look at mine a minute. I can see that I'm going to go through P, and I'm going to go through either there or super close to there. So just see how close you can get that. And compare with your partner, because I, 7th hour, am not going to be there to walk around, and I'll be walking around in just a minute after I finish this one, to kind of check how yours look. But check with your neighbors so you can kind of tell how those are working out. Now, this does have a question attached to it as well. Let's call that circumcenter point A. And for those of you in the room right now, and you, even if it's 7th hour, are they at the same point or close? Give me a head nod. I need to see that. And I'm actually coming around in 1st hour just to see if you would point to kind of where they intersect. That just helps me be able to look kind of quickly. And maybe the teacher will walk around and look at those as well. And that should be the circumcenter. And so then, just to kind of validate what a circumcenter is in our head, that is the center of, just a second, let me find, there we go. That should be the center of a circle that has radii a y, a z, and a x. So let's just kind of see how that worked for ourselves. And I have to turn this a little bit so I can use it here. So put the point, now you're going to use the compass. We're really using it just to check ourselves. So as carefully as you can, and I'm actually going to make mine on Z to begin with. Oops, because I'm having a little trouble there. There we go. And I'm just going to use some light color. Let's see. Oops. Or I'll use red. That's the color I'll use here. And then if you draw that circle, it's like you're testing how well you did on that. And your circle should touch X, Y, and Z. Just to kind of, and that we're just doing, yeah, to check this. If that is actually indeed kind of, and you know, if it's not perfect, that's okay. It should be, you know, fairly close as we go through this. And if it's not, then we know that's a little bit because of the of just error in measuring and things like that and marking things. So you want to write on your paper so you know A is circumcenter, circumcenter. And the question on our notes here, not on your handout, says a triangular shaped garden is shown. Can a fountain be placed at the circumcenter and still be inside the garden? And the answer to that is no. No, the fountain is outside. Oh, let me get rid of that. Is outside of the, and we're going to add a word here, of the obtuse triangle. And it's because that triangle is obtuse that it's outside. Outside of the obtuse triangle. So now for 2B, we're going to do this second picture, and now we just have a triangle. We're going to find the circumcenter again, and so I'll just kind of do this as you're doing it, and hopefully you're measuring things. I won't ask what your measures are. I'll just kind of tell you what is happening here. So for that, you're going to find the midpoint of each side. So take a minute, find the midpoint of each side. And once you have the midpoint of each side, let's label those again M, N, and P, just to know that those are the midpoints. So we're really kind of making sure we know where this circumcenter is and what its relationship is to this triangle. So we have the midpoints. Once you have the midpoints, make that perpendicular line at each one of those midpoints. And this does not appear to be an obtuse triangle, so my expectation is that these are going to intersect at a different spot than last time. So take a minute, and if yours wasn't right on last time, you might want to, just try to see if you can be a little bit more careful as you go and see if that works. And so each one of these, I'll kind of put it at that hole and line it up for my 90 degrees. And it looks like mine are going to be pretty much right in the same spot again. Notice this time, at least mine, and yours should be the same, mine are intersecting inside of that triangle, and so that's an acute triangle. Let's call this circumcenter point B. And then we'll say circumcenter capital B is inside, and this is an acute triangle, the acute triangle. And then just as a check, let's take a compass again and kind of see if we can put that on there. So what should be true is that point B should be equidistant from F. Oh, and the other F. Do you see that? And D. So let's actually change one of those F's into an E. I just changed the right one into an E. That way it'll be kind of consistent there. And you can check yours. I'll use red again this time. Put the point on B, and then your pencil on one of those F's, or E or F or D, and kind of just see if you can get it right in there. And then if you draw that circle, it should touch each one of those. And I think that gives us a better sense of what is circumcenter, what exactly is kind of happening there as we look at that. So that's the circumcenter, and we had some problems related to that. And maybe check with your neighbor again just to make sure that's working out for both of you. Now, while we have all of our equipment out, I'm going to ask you to find the handout that has the triangles on it. And I'll go to that page as well. So find that handout with the triangles. So on the note page, which was big, we have circumcenters. Now, bless you, now we're going to find incenters. And there's two ways that we can do that. So we have two triangles. We're going to do that in two ways. One way is to construct the angle bisector. And in this case, that might be the easiest. So now we're going to use our compass a little bit more, and we're going to construct angle bisectors. And if you're not sure, and our pictures aren't huge, so that first arc you're going to make, try not to make it super big, but you want to have something that's workable. So I'm going to go from point B here, and I'm going to put my point at point B. And we did this like at the end of chapter 1. And you need to strike an arc that hits angle B on each of its sides. So angle B has the 2 sides. So as long as it hits those 2 places right there, I'm good to go. And then from those 2 places, I'm going to put my point, and so you just have to kind of look at the slide where the arc intersects the side of the angle, and I'm going to get that little X out in the middle there. If you want to open it a little more, you can if you're not sure if it's going to be kind of out there where you can see it. But from the point being, and look at the smart slide kind of carefully there, the point is right where the arc intersects segment, I think it's BC, I can't really see it. And then out in the middle, you're going to make a little arc. And then hopefully, you know, that's kind of in where the midpoint is going to, or where that angle bisector is going to be. And then you're going to put the point at the other place where that first arc hit the side. And then you're going to make that second arc, and that should be your X right there. And then we'll label that point M. And then draw a ray from B through M. So draw that ray from B through M. And you're using a ruler, of course. I'm just using the straight line drawer, so it should just work out for me. And then you're going to do that exact same thing 2 more times. And remember, now we're going to be finding the in-center. And we said yesterday the in-center is always inside of the triangle as we do that. So now I'm going to go over to point C. And at a convenient opening, whatever you're kind of liking there, I'll use just a different color. You're going to strike an arc so that it hits there twice. And then from that one of those arc to arc intersections with segment BC or with CA, then you're going to make another arc out in the middle someplace. And then you're going to put the point on that second spot where that first arc hit there. And then at that same compass opening, you're going to make that X. And then once you have that, you're going to draw that line with your straight edge. And you should be realizing that, you know, using a straight edge is important in this part because we really want to know where those are going to intersect correctly. And then you're going to do the same thing at angle A. And I'll just use a different color. I have to bring this around so that I might just make that opening a little smaller there. And then I'm going to make that arc. And then from one of those, I'm going to make an arc out into the middle. And I have to make it kind of long because my compass was away there. And then another one. And once I have those, then I'm going to draw that line. And if I did a super good job, they should all hit in the same spot. We'll call that point C. And we'll say point C is the in-center. Point C is the in-center. Now, the deal with point C, and I think we might not do that other one unless you want to do it on your own. You sure can. The deal with the in-center, and I don't have something like you have that I can measure and angles and lengths with at the same time. But you can. So if you'll take your protractor now, and this is what I want you to do. I want you to put it here so that it's along BC and it's at 90 degrees. And I can't measure this, but I want you to measure the distance from C to line, or, oh, I'm sorry, I called that point C. I have to name it something else. I think D, E, F. Let's change that C into a G, and I apologize for that. That way we're using all different letters. So find the distance from point and perpendicular distance, and that's how we find distance. So you want something to be perpendicular to BC, and I want to know the distance from G to BC. And I need somebody to tell me what that is in this hour. What is the distance from G to the line? So there's no point there. There's no point right there that you're finding. So you're just measuring from there to there and seeing what that distance is. What is it? About 1.8. So that's about 1.8. Now do the same thing for the other lines. So put this so that it's at 90 degrees to side AC, and then slide that down and measure from G. And you might even, another strategy you might use is you might have your ruler and just put it right next to, let me see, if you put it right next to your protractor, oops, then you can kind of measure along the ruler, kind of sitting along the protractor. Give me a head nod. Is it about 7 before? Is it about 1.7 again? And what do you anticipate from G to line segment A, B is going to be? It should be 1.7. So take a minute, do that one also, just to kind of validate that those are 1.7. And our theorem in this section says that, or one of our theorems, because we have a lot of them, says that that in-center is equidistant from each of the sides. We have a kind of a theorem that says that, and maybe if I can find it, I'll read it to you. The angle bisector theorem, if a point is on the bisector of an angle, oh, just a second, I think I'm reading the wrong one. Here it is. The angle bisectors of a triangle intersect at a point called the incenter that is equidistant from each side of the triangle. So its distance from point G to each side of the triangle should be the same. And then another check we can do for that is put your point at G and then your pencil very carefully at that 1.7 mark. So you might even want to take your ruler and open that so that it's open to 1.7. And I can't do that with mine, but open it for a 1.7 opening, and if you draw that circle, it should touch each of those sides, and mine did not. So let me kind of put that in there again, and then I can figure out what my radius should be. Oops. So I didn't have a ruler to measure, but this one should be a little better. Ooh, mine is not great. And I think this one is just a little harder to do than the other one of putting that circle there, because we have to know that length of the radius. But it should be an inscribed circle for that, and it should hit each one of those just one time. So I can kind of make it work a little bit better for myself. That'll be about where that is. So you should have that. And we're not going to do that other one because we still have to do problem number 4. But that is the in center. And now we're going to go to, let's see, to 3A. Nope, just kidding. We did the 3 ones. I have to find 4A. So 4A is now the in center. And so look at how they've written this on here. We have the in center, and it just happens that these are the same distances. Sometimes that's going to be a little bit different as we look at that. And I'm going to tell you that in my opinion, this is not the in center because that distance, and that distance are not the same, SR, SU, and ST. But we'll just go with the picture that we have. So we want to find SU. I'm going to shade it on this picture. And we know it's the in center of triangle MNP. And so we have a right angle right here. We know this is 8. We know this is 10. And so we'll call this side little a. And we're going to use the Pythagorean theorem to find that. And so by the Pythagorean theorem, a squared plus b squared equals c squared. Since the right angle is here at angle SUP, then we know side C is the 10, and we'll call the 8 the b. And so we can say a squared plus 8 squared equals 10 squared. Subtracting 8 squared, a squared is 10 squared minus 8 squared. Square rooting that, when you get into algebra, when you square root each side, it's going to be plus or minus, but since in geometry we're talking about lengths, we'll always use that. It's called principal square root or positive square root. So square root of 10 squared minus 8 squared. You can use a calculator for these. This one works out pretty nice though. 100 minus 64 is 36. So A is the square root of 36. So A is just 6. So that means that here SU is equal to 6. And I'm not super thrilled with this picture, just to kind of let you know. This is not my favorite picture because I don't think it's drawn super well, but we'll manage it as we go. Then the next problem, same picture, has to do with angles. And these are supposed to be the angle bisectors since this is the in center, and so it doesn't really look like it, but will you mark this 31-degree angle and the one next to it as the same? So it is also 31. I can kind of sneak that in there a little bit. Mark the 28-degree angle with 2 markings and the one next to it the same. So those are 28 and 28. And we're asked in this second picture to find the measure of angle SPU, so from S to P to U, and we'll call that like a little X in there. And we know that these two are the same, so mark those with 3 markings. And so I'm just calling them both X. And in that big triangle, triangle MNP, we know that the sum of those angles is 180. So I'm just going to write the measure of each of these big angles. The measure of angle MNP is the 28 plus 28. So that is 56. The measure of angle NMP, where M is the vertex, is 31 plus 31. So that one is 62. And then we know that the measure of angle, and I'll call it NPM, let's call that 2x because it's x plus x. And then if we can find x, that will be the measure of angle SPU. So remember the sum of the angles of a triangle is 180. So 56 plus 62 plus 2x equals 180. And then I'll just do this. This is 118 plus 2x equals 180. And then as we solve for x, subtract 118. And then 2x equals 62. And divide by 2. And x equals 31. And so that means that the measure of angle SPU equals 31. Now, the next things that we're going to do here are we're going to write our questions and summaries. So let me kind of find that slide. We're going to write our questions and summaries, and now we're going to glue everything in. So I'll get out the glue for you, and you're going to write questions and summaries and glue things in. And then just a reminder that homework 1 is due on Friday.